what he is asking. Okay. In this question, what he said, forward bias PD is 0.5 volts. Safe limit of current is 10 milliamperes. It is connected to 1.5 volts of cell. In series to the diode, what is the minimum value of resistance to be connected? I think you understood. What will be the answer for this question?
1 by 10 milliohm.
1 by 10 milliohm means 0.1 milliohm or else 100 ohms.
Sir, 100 ohms.
100 ohms, pakka.
Pakka, sir.
Okay, fourth question.
సార్ అంటే మనకి ఇప్పుడు వోల్టేజ్ ఏమో 1 వోల్ట్ ఉంది కదా సార్, మనకి కరెంట్ ఏమో 10 మిల్లీ ఆంపియర్ మాక్సిమం, సో రెసిస్టెన్స్ ఏమో 1 by 10 మిల్లీ ఓమ్.
ఓకే. Fourth, third option, 100 ohms, I think correct. He is, Mr. Aryan is correct.
100 ohms, sir.
100 ohms, na?
Yes, sir.
Yeah. 1 by 10 kilo ohms, I think that is correct. 1 by 10 kilo ohms means 100 ohms. And you are also saying same, na, Manduva?
అంతే సార్, అంటే మనకి 1 వోల్ట్ వచ్చేలాగానే రెసిస్టెన్స్ కావాలి కదా సార్.
Yeah, అంటే V minus VB you are saying.
అవును సార్.
Okay, good. V minus VB అంటే 1.5 minus 0.5, that is equals to 1 volt. What you said is correct. Voltage across resistor. So V is equals to IR, you are saying. Antena?
Yes, sir.
Then your answer is correct. 10 milli. Milli means 10 power minus 3 into R. I think R is equals to 1 by 10 into 10 power minus 3. That is 100 ohms. Yeah, exactly. And here, ఇది ఒక్కటి అర్థం కావాలి నాన్న. Indirectly, he said that in forward bias, the PD across the diode is 0.5 volts. అంటే it is the barrier voltage. And if you are able to understand, then the answer will be very easy.
Sir, V minus VB is equal to 0.5 కాదా? అంటే పొటెన్షియల్ డ్రాప్ అంటే మొత్తం ఫార్వర్డ్ బయాస్ లో V minus VB కదా సార్ జంక్షన్ దగ్గర.
Yes, V అంటే yes, V is 1.5. This is 0.5. VB is 0.5. Total is not 0.5 కాదు.
V minus VB is not 0.5 సార్.
అయ్యో, నీకు ఇంకా పూర్తిగా అర్థం కాలేదు కదా ఆయన. ఎవరిది అడిగింది?
జయరామ్ సార్.
జయరామా? అయ్యో జయరామ్, నువ్వు అడగడం ఇంకా బడుద్దాయి. ఇది రెసిస్టెన్స్, దిస్ ఈజ్ సెల్. ఇది 1.5 రా. V minus VB అంటే ఏమనుకుంటున్నావు? The voltage across resistor is V minus VB రా నాన్న. ఇది V, ఇది VB.
ఓకే సార్.
ఈ 1 అర్థమైందా? ఈ 1.5 అనేది స్ప్లిట్ లైక్ 0.5 and 1. ఇప్పుడు క్లారిటీ వచ్చేసిందా?
అర్థమైంది సార్, అర్థమైంది.
Good. This is the resistor. So V minus VB is the voltage across resistor, not across the diode. Diode వచ్చేసి VB. Right.
Okay sir, thank you sir.
Okay, good. Right. This was given in 3rd September 2020. Simple question. Why I am saying these questions అంటే ఎగ్జామ్ లో వస్తున్నవి హౌ మచ్ ఈజీ ఫ్రమ్ సెమీకండక్టర్ డయోడ్స్ అనేది ఒక్కసారి మీకు ఐడియా వస్తుంది కదా అని ఐఎమ్ గివింగ్ దీస్ క్వశ్చన్స్ నాన్న. ఓకే, దిస్ ఈస్ one question from September in 2020 and one more question in the same 2020 అంటే this year అంటే for your seniors exactly. One more question given, but in January test he gave the diode question like this. Like this is one V-stone bridge, Nana. Okay, I'm taking one V-stone bridge here like this. He gave for this V-stone bridge in the middle. He connected something here. Here he connected one diode. This is the diode what he connected here. Okay, and here better I go with another color, dark color. Suppose this is the diode what he connected here like this, and one more resistor is there like this, and here one more resistor is there like this, and here also one more resistor is there like this, and this is 10 ohms and that is also 10 ohms, and it is 5 ohms what he gave, and these are two diodes. Here one more diode he connected like this. This is one more diode and one more resistor is there here. This is 20 ohms. Okay, and finally this is connected to, as usual, one 5 ohm resistor here and a battery, 9 volts battery. Okay, better I draw somewhere here, and 9 volts battery. It is connected as usual like this. Okay, and then here connected like this, and here also connected like this. Okay, this is the circuit now what he gave here, right? And in the middle one more resistor he connected. In the middle one more resistor is there. Okay, here one more resistor, that is 5 ohms, exactly like V-stone bridge but with the two diodes here. Okay, then he is asking what is the current through the circuit. Means he gave here, this is I. Simple, in the question he gave this circuit and he asked the current I in the network is.
Sir, ideal
That
diode, sir.
వాడే మెన్షన్ చేయలేదు కదా, లైక్ ద రెసిస్టెన్స్ ఆఫ్ ఈచ్ డయోడ్.
అవును సార్.
రెసిస్టెన్స్ ఆఫ్ ద డయోడ్ నాట్ మెన్షన్ అంటే యూ హ్యావ్ టు కన్సిడర్ దెమ్ యాజ్ ఐడియల్, ఇక తప్పదుగా మనకి.
ఓకే సార్.
సో దిస్ వాస్ గివెన్ 9th Jan 2020. Then what is the answer for this question? Waiting
Sir,
for
9 by 30.
9 by
30.
9 by 30 means how much? 3 by 10. 3 by 10 means 0.3 you are saying.
Yes, sir.
Ramaditya 0 na. Array, it is not correct. 0 is wrong. I think maybe.
సార్ అపోజ్ చేస్తున్నాయి కదా సార్.
సార్
1.5 నాన్న వైష్ణవి.
1.8 సార్. 1.8 amperes.
1.8 wrong nana. I don't know how you got 1.8. What's your method?
సార్ అంటే రెండు అపోజ్ చేస్తున్నాయి కదా సార్ కరెంట్ ని.
These two yes, అపోజ్ చేస్తున్నాయి.
సో అక్కడ నుంచి పాస్
కరెంట్
పాస్ అవ్వదు కదా.
yes, కరెంట్ పాస్ అవ్వదు. Then what? మరి నెక్స్ట్ యువర్ ఐడియా చెప్పు, ఫస్ట్ నీ ఐడియా.
సార్ కానీ ఈ 10 ohms
అంటే
5 ohms 10 ohms సిరీస్లో ఉన్నట్టు
మరి నీకు అప్పుడు హౌ యూ గెట్ 1.5
9 బై
నీకు రాదు
30
కదా.
అవుతుంది సార్ అయితే.
యా 9/30 అంటే 0.3.
ఎస్ సార్.
యా ఇప్పుడు కరెక్ట్. సో హియర్ when current starts flowing like this is in reverse bias. That's why current does not flow. So why? Because ideal diode infinite resistance, so it does not allow the current. So current comes like this, and again here at this junction actually current should split like this, but again current suppose splits, it has to flow in this direction, reverse bias, so it does not allow, but there is a chance to flow like this, so goes like this, and then as usual it comes like this. Okay, and that one directly flows like this, and that reaches to the battery. That's why here current is not splitting anywhere, all they are in series. I think now you understood. Okay, so the total resistance in the circuit, I say all they are in series means 10 plus 5 plus 10 plus and here 5. Total resistance I am getting 30 ohms. That's it, over. Therefore I is equals to total voltage in this is 9 V by R, using that formula 9/30 is correct, I think. So 3 3s are 3 10s are, that is 0.3 amperes. Option is there, we have to check it. Okay, 0.3. మళ్ళీ చెప్పరు, అట్లా చెప్పేటప్పుడు వినాలి. This is question number, oh you don't know, sorry. 0.3 amperes, correct. What is this, Ramaditya? When the current comes to here, actually it has to split into two ways. But if current splits, the current is trying to flow in reverse bias through the diode. In reverse bias, it does not allow. That's why current won't split at this junction. Whatever the current that directly flows through this 10 ohms. Current is not coming to here. That's why it is open. Okay, that's why there is no way of assuming like current splits like this and like that in Wheatstone bridge. Why? Because no current is coming to there. So directly the current is coming to here. Again we are checking, this is a junction, it is finding out two ways. Again, if the current were supposed to be splitted in two ways, the current should flow through the diode in reverse bias. Reverse bias does not allow. That's why current won't flow through it. That's why without splitting, the same current flows through this resistor. Again, current won't split like this at this junction. Why? Because it has to come back to positive terminal. Positive terminal current won't come. That goes to the lower potential, negative terminal. That's why at this junction, again, don't ask, currents are may split like this and like that. That won't split. Straight away it goes towards the negative terminal. That's why here there is no splitting at this junction. Why? Because already it is opened, and directly here the current flows through this resistor. And again, don't ask, sir, current will split like this. That is foolishness. Okay, if you ask like this, you don't know, you know nothing in current electricity. Again, it won't go back like this. That's why whatever the current coming here without splitting, that directly comes to this junction. No current is coming through this diode, from this diode. That's why it is open and directly flows like this. Means the circuit is appeared like this. Now you understood? Here it is open. Here it is open. Mr. Ramaditya. 4 resistors are in series. No splitting of current here. This is open part. That is also open part. So open part, if you leave them, then the circuit will be appear like this. All they are in series. Okay. All they are in series means total resistance. Yes. Not a balance. Who said that is a balanced resistance bridge? Okay. right? If it is forward biased, then we have to check whether it is a balanced Wheatstone bridge or not. If the diodes are connected like this, then we check 5 by 10 and 10 by 20 sir, that is balanced Wheatstone bridge sir, so no current flows through this 5 ohms sir, then we do like in current electricity. Okay, right, good. Oh my goodness. Array, 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 right. This is the circuit now, what we discussed, and this was given already I told January 2020 only. Likewise, here few questions he gave Nana, right? So I think you got some idea how to solve the questions related to the diodes part. When they are in reverse bias, what happens? When they are that is in forward bias, what happens? Now you got some clarity, Nana?
Yes, sir.
Right. I think this is enough for your practice. Okay. So yes, I think you got the idea. Then we will move to another concept. Okay. Here still we are having some dissatisfaction in using the junction diode. Okay, why? Because we are habituated to what, to see the empty space in the bottle instead of the filled space in the bottle. Okay, which is not there with us. We think about that. We never think about which is there with us. Okay, and we never satisfy with that which is there with us. We are always worry about the things which are not there with us. So here also the same habituated thing, what I am saying, same means same habit. Why you are dissatisfied with this junction diode? If I ask you, what do you say?
Means, sir, less current
No.
with
No. I think you are dissatisfied for the reason that SAR told this this junction diode should not be used in reverse bias. Okay. Why? Because it is offering more resistance and does not allowing the flow of current. A junction diode we constructed should be used in forward bias only. If I am able to use this one in reverse bias also, I feel so happy now. Okay, so little bit dissatisfaction is there. Array, bad luck. We are not able to use this in reverse bias. This is what I'm saying. You are seeing the empty space in the bottle. Okay, whereas it is giving good result in forward bias. You are not seeing that. You are not seeing the good result. You are just seeing the bad result only. Not able to use this in reverse bias. If it is so, I think it is pinching inside. That's why here, for your sake, for your satisfaction, Papam, the scientists, they tried to develop another kind of diode, which is to be used in reverse bias also. Okay, that type of diode, they named it as Zener diode. Scientist name Nana Zener. Okay, this Zener diode, particularly for your sake only, they prepared, particularly to use. That's why in bracket I am writing particularly to use in reverse bias without breaking. Why you are unable to use that in reverse bias, Nana?
Heavy
more
current
The
will
ordinary,
flow.
Yeah, the ordinary diode, heavy current flows, but problem is if you increase the applied voltage beyond a particular limit, it burns and breaking, correct? At the junction.
Yes, sir.
That's why you are not interested to use that in reverse bias beyond a particular voltage. So you asked, sir, if I use that in reverse bias, I feel so happy, sir, without breaking and without burning. Okay. Then they prepared one Zener diode. How they prepared, sir? Just watch here. This is, as usual, the P region, and this is the N region. What the modification they did? Okay, that means they studied particularly where we are getting the error in Zener diode, sorry, ordinary diode. Where you got the problem there, particularly here, if I take the graph, VI characteristic, there in forward bias, no problems arise. Happily, I used it. Okay, I got a graph up to barrier voltage. Okay, this is a common thing. No current will flow. It is quite common. And beyond that, I got the current exponentially increases like from barrier. This is knee voltage, as usual, we call it as, which is equals to the barrier voltage, which is equal to the barrier voltage. Okay. Reverse bias, what the problem you got there? Up to here, the current increased slowly like this. But when you increase the voltage beyond a particular limit here, I got a breakdown somewhere here. This is called the avalanche breakdown, VA, avalanche voltage. Okay, of course, up to here, you can use it up to you get the avalanche breakdown, but very small amount of current flows. Okay. At avalanche, the problem is suddenly the current increases very sharply and breaking the bonds. Okay, covalent bonds and resulting a lot of generation of heat and breaking of covalent bonds means resulting cracks to the crystalline structure. That problem what we found in ordinary diode. Okay. Oh, we understood. Suppose this is the germanium crystal. We found the avalanche breakdown. And here for the, suppose germanium crystal, I found this avalanche voltage. Okay, say suppose some value like 5 volts. Okay. Oh, I have to use this at the voltages less than 5. It won't break. That's why now keenly observe what I am saying. This is important point in Zener diode. The thought what they got. If the voltage applied is less than 5 volts, the diode breaks, Anana?
No, sir.
No, sir.
Diode will be survived or not?
Survived, sir.
Without breaking. That's why what the idea they got, okay, we get this breakdown, not at avalanche. Why? Because the diode is breaking. Suppose I get this breakdown voltage in another diode somewhere like this, here only. Okay, this is the breakdown voltage. Which is less than the 5 volts where the covalent bonds are broken. If I'm able to get that breakdown voltage here a bit early, then I think the diode will not be broken. Am I right? Here, are you following?
Following.
Yes,
I think
yes,
some
yes.
doubt is there. I think some doubt is there in your mind. What I understood, you took more time to respond. Sir, how to bring this breakdown a bit early? That is your doubt. Okay. For that, he is saying here, Nana, compared to the ordinary diode, here, first point, what he says, it is doped like here, third group, and there, fifth group, doped heavily, Nana, compared to the ordinary diode. Means they increased the doping concentration on both the sides. With the increase of doping concentration, what happens? More number of majority charge carriers will be developed here. Suppose previously I took in a row 4 holes, or likewise 1, 2, 3, 4 rows I drew. This time in a row I'm taking 5, and likewise 5 rows I'm drawing here. You compare with the ordinary diode, my diagram. Means you observe here the previous diagram where I drew in the ordinary diode, and here this diagram drawn in Zener diode. Compare where you are finding out more majority charge carriers. Nana, I will draw one more row here. Where
This
you are
one.
finding more majority charge carriers. This one only. This is what I'm saying. Okay, 1, 2, 3, 4, 5. Likewise, 1, 2, 3, 4, 5, 6 rows I drew there. 1, 2, 3, 4, 5. Whereas I remembered in my previous diagram, I drew only 4 rows. You can cross check. So here majority charge carriers number is increased, Nana. And that too, when majority charge carriers number is increased, number of rows increased. In case of unbiased diode, if it is Zener diode, what is the barrier voltage? 0.3 volts. Na?
Yes, for Germany.
For germanium. So in case of barrier, I get that 0.3 volts, maybe just with one row only. Why? Because I am getting more number of ions here, okay, in a column. Previously, I think I drew only 4 ions. Actually, 1, 2, 3, 6. Kada. So I have to draw 6 positive ions here and 6 negative ions. Okay, suppose 3 plus 3 in 2 rows, okay, sorry, 2 columns, results the voltage of 0.3 volts. Now I am getting with only single column or not, Nana?
Getting, sir.
Are you fun? Easy. Ordinary diode, like suppose if you drew like this in the previous case, and totally I require 6 ions, Nana, to produce 0.3 volts. And say one example I'm taking. Okay, 6 ions. Those 6 ions are formed in a single row here, sorry, single column here, instead of 2 columns. Instead of 2 columns, single column is giving 0.3 volts. Means what happens to the depletion layer, thickness of depletion layer?
Reduces.
Previously, this is what I'm saying. So in this case, unbiased diode, you can say straight away, the thickness of depletion layer will be decreased. So next point I'm writing here. Sorry. In unbiased diode. Okay. Good morning, Ritik.
గుడ్ మార్నింగ్ సార్.
ఏమి చర్చికి పోయిచ్చావి?
5 అవర్స్.
అంతేలే, మమ్మల్ని మర్చిపోతారు మాస్టర్. మేమంత ఇంపార్టెంట్ కాదు కదా.
లేదు సాయంత్రం.
రైట్, ఏమోలే, క్రిస్మస్ కదా, చర్చికి పోయిచ్చావు, లేట్ అయిందేమో అనుకున్నా. Okay, right. In unbiased diode, here what he is saying, the thickness of depletion layer depletion layer decreases. Okay, suppose previously it was in millimeters, maybe this is decreased to micrometers. Okay, and the difference you can find out there. Okay, and a small depletion layer there, but barrier voltage in the case of unbiased diode 0.3 volts. I think you get a strong electric field here, Nana. Why? Because E is equals to V by L. Na?
Yes, sir.
So this is what he is saying. Strong electric field is developed. Sorry. Dendra tapu draw chesanu. Here I have to take negative ions kada in P side.
Yes.
Yes, sir.
Okay, right. And there I have to take what? Double the work. Okay, right.
సార్ ఎరేస్ చేయకుండా ఒక గీత పైనుంచి గీయాల్సింది.
నాకు అదే ఐడియా వచ్చింది, అరేస్ చేసాక వచ్చింది ఐడియా. ఓకే, రైట్. హియర్ then what I have to take here, negative ions 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. Okay, right. So electric field from positive to negative, you will get like this. This is the direction of electric field. And according to the formula here, the depletion layer thickness is decreased. That's why strong electric field you can find here. This is the next point what I'm going to write. Since I write E is equals to VB by L at the junction. Strong electric field is developed. Okay, keep in mind, Nana, that implies kinetic energy is increased. What do you say? Is the kinetic energy increased, Nana, here?
Yes, sir.
How, Nana, kinetic energy is increased?
సార్ కైనటిక్ ఎనర్జీ సేమ్ సార్, VQ no sir, వర్క్ డన్.
Kinetic energy is VQ and a VB into Q, that is same. But force F is equals to EQ. This is increased. Now you understood?
Okay, sir. Understood.
So by this what happened, suppose if you connect this in reverse bias, okay, the voltage may be increased like V plus VB. So little bit the kinetic energy is increased at the less voltages here. But here the strong electric field tries to push those minority charge carriers from one region to another region. Means here not pushing like in a queue, just pushing like in during the time of that what agitations, Nana. Okay, how the police persons push the mob. Okay, like with large force will be there, but less kinetic energy is there for the charge carriers. Now you understood this point, Nana?
Yes, sir.
అండర్స్టూడ్ సార్.
So quickly they cross the junction, but with less kinetic energy. Okay, means acceleration is more, but kinetic energy is less. By that, what happened? While crossing the junction at more acceleration, surely they strike the covalent bonds, no doubt at all. But since their kinetic energy is less, they are unable to break the bonds. But after certain potential, you can observe that somewhere here, they may knock out one electron from the covalent bond without breaking the bond. Why? Because they don't have sufficient energy. That energy they get somewhere here to break the bond. But here, this potential, while crossing the junction, they may knock out the electrons from the covalent bonds, and one becomes two. I think no need to explain. These two electrons may knock out two more electrons from the covalent bonds, altogether four. Okay, one became two. Sorry, actually three. Along with one became two only. Sorry. Okay, are you confusing or follow Nana here?
Followed.
Sir.
One knocks out one more electron, altogether two. Two knocks out to knock out two more electrons, altogether four. Four again knock out four more electrons, altogether eight. Means again the current number of charge carriers increased in geometric progression, no doubt at all. It is also should be called as avalanche. But problem is they are not breaking the covalent bonds. Keep in mind, not breaking means the diode breaks here at this particular voltage.
No,
The
sir.
diode breaks, Anana.
No, sir.
Diode is not breaking, but suddenly you see more number of population of electrons here, and along with the holes also, Nana. Why? Because covalent bond is not broken. Suppose here 8 electrons came out, means along with the 8 holes are there. Okay, suddenly the charge carriers number is increased. Charge carriers number is increased means suddenly the current through the diode will be increased. So you will get a sudden growth here also. Okay, where you are getting a sudden growth of current, I am calling that voltage as breakdown voltage. Okay, without breaking the diode. This was found by Zener. That's why I call it as not avalanche, giving the respect to the scientist. I'm calling it as Zener breakdown. Okay, that is avalanche, and this is Zener breakdown. Now you identified the difference between Zener breakdown and avalanche breakdown, Nana?
Understood, sir.
Very good. Here I can say from that, in forward bias, no difference in the functioning of ordinary, that is junction diode, and Zener diode. Why? Because that is in forward bias. Forward bias, we did not find any difference. That will be like this is the knee voltage and as usual exponential curve. This is for both junction diode and Zener diode. Okay, in forward bias, I'm not finding out any difference, but I am finding out lot of difference in reverse bias. Okay, this is in reverse bias, but in reverse bias, I write here. Okay. But in reverse bias, the diode gets the breakdown okay earlier than the avalanche breakdown. Okay, thus I write the next point here. Thus it sends any amount of current without increasing the voltage. Without increasing the voltage. That you can see here. At that voltage only, Zener breakdown voltage only, it is sending any amount of current. 2 microamperes, 3 microamps, 4 microamperes, 5 microamperes, 6 microamperes, 10 microamperes, any amount of current it is sending. But voltage, breakdown voltages will be same. At that voltage only it is sending. Okay. That's why what they say finally, oh, you can send any amount of current even in reverse bias flow. Na? Yes, even in reverse bias, I'm able to send any amount of current without breaking. Yes, without breaking only. Okay. That's why here, why don't you use this particular diode only in reverse bias at Zener breakdown voltage, not to increase the potential drop across an appliance, like voltage regulator, stabilizing the voltage. That's why it is in, when you come to our daily life, it is used as a voltage stabilizer, regulator, or stabilizer at the breakdown voltage. Breakdown voltage without increasing the potential. Okay. How you maintain a constant potential difference at the breakdown voltage across your appliance? Simple. At the breakdown voltage, here the voltage is not increasing. Voltage is not increasing means you just connect. Here it always maintains some breakdown Zener voltage. No, let it be some VZ. Okay. That VZ is constant across the diode when it is connected in reverse bias. So suppose that VZ is by changing the doping concentration, if you connect, change it to 230 volts, that Zener voltage, okay, means where the avalanche breakdown for the same diode may be like some 240 volts. Okay, I got bit early, so the diode won't break. Okay, and at that 230 volt, all Indian appliances will work. That's why you connect your appliance across this in parallel. In parallel, already I told, you know, of course, no need to say, the potential drop is constant. That's why here, any external resistor means appliance can be connected in parallel to Zener diode. Zener diode. Of course, in reverse bias. In parallel to Zener diode at the breakdown voltage. Okay, then happily it maintains the constant breakdown voltage and external resistors. If you connect it across the Zener diode like this, Nana, suppose this is the diode, I did not say the symbol, I will tell the symbol. Across the Zener diode, you connect one resistor like this in parallel. Whatever the breakdown voltage, same breakdown voltage will appear across your appliance. So you are stabilizing without changing the potential drop across this resistor. You can maintain the potential difference constant. Means like a stabilizer. Inbuilt stabilizer. This word in all appliances nowadays we are seeing. Refrigerator, TV, everything, whatever you purchase, they say inbuilt stabilizers are. Inbuilt stabilizer means just one Zener diode is connected at the input. That's it, in parallel. Now you understood the concept of Zener diode, or any questions here related to it?
Understood.
Any questions? Anyone? I am
Sir,
going to stop the class.
Sir, one doubt.
Yes.
Sir, suppose like we connect one Zener diode to some appliance, like some TV or something, in parallel only. Suppose some time at fluctuation, we get some like 280 volts or sometime fluctuation time.
Means less than the voltage 230.
No, more than, sir. Means like some high voltage we get, sir. Like 250 or something.
Okay, in India we require 230 volts, Nana. So like you are saying 250 volts.
Yes, sir. So sir,
Yes.
across the Zener diode also we'll get 250 on.
That I will explain tomorrow.
Okay.
Okay. Right. Good.
సార్
So here the symbol of yeah.
సార్ అంటే ఇప్పుడు జీనార్ డయోడ్తో స్టెబిలైజ్ చేయగలిగినప్పుడు అంత పెద్ద స్టెబిలైజర్ ఎందుకు వాడతారు సార్?
అదే క్వశ్చన్ వస్తుంది కదా పెద్ద, నాకు తెలుసు నువ్వు అడుగుతావు. అందుకే టుమారో ఐ విల్, అంటే ఇన్ ద నెక్స్ట్ క్లాస్ ఐ విల్ ఎక్స్ప్లెయిన్ అని చెప్పింది.
ఓకే సార్.
ఓకే. మనకి ఎప్పుడు కూడాను ఉన్నదాంతో సాటిస్ఫై కాగా ఇదైతే ఏమవుతుందని లేని దాని గురించి ఎప్పుడు వరీ అవుతుంటాం. సో హియర్ అదే క్వశ్చన్ ఆబ్వియస్లీ అలా ఉండాలి, ఫిజిక్స్ అలా ఉంటేనే ఫిజిక్స్ వస్తుంది. సో వీ హ్యావ్ టు థింక్. ఓకే, మన ఫిజిక్స్ వాళ్ళం ఎప్పుడు కూడాను వీ హ్యావ్ టు సీ ద ఎంటీ స్పేస్ ఇన్ ద బాటిల్, నాట్ ద ఫిల్డ్ స్పేస్. అప్పుడే మనం ఫిజిక్స్లో డెవలప్ అవుతాం. సో ఇట్స్ ఎ గుడ్ సైన్ యాక్చువల్లీ సీయింగ్ ద ఎంటీ స్పేస్. అది ఐ విల్ ఎక్స్ప్లెయిన్ ఇట్ టుమారో, I mean in the next class. This is the symbol of Zener diode, Nana. Did you find any difference between ordinary diode symbol and Zener diode symbol?
Yes, sir.
Yes.
Here I think you find the ordinary diode generally we draw like this, correct?
Yes, sir.
Just I drew this part as Z. And if you see that directly we can say, yeah. Directly by seeing that symbol, oh, it is like Z. Z means it is a Zener diode. Okay, Nana?
Okay.
For the N type, P type we are not doing any change in the symbol, Nana. P as usual arrowhead. At the N, just we are putting like Z. This is the symbol of Zener diode. Okay, keep in mind if you connect it in forward bias, no farak, Nana. Okay, so we have to use Zener diode to prepare చేసావు అంటే for what purpose you prepare? To use it in forward bias or reverse bias?
Reverse bias.
Forward bias మనకు ఆల్రెడీ ఆర్డినరీ డయోడ్ ఈస్ దేర్ అండ్ ఇట్ ఈస్ వర్కింగ్ నైస్లీ కదా, దానికి ఎందుకు మనకి. సో వెన్ యూ కమ్ టు న్యూమరికల్స్ ఆల్సో యూజువల్లీ యూ సీ దిస్ కనెక్టెడ్ ఇన్ రివర్స్ bias. Okay, Nana? That we will do the numericals and the doubts what you raised we will discuss in the next class. Okay, this is the first page, Nana. Is it over?